Get this started. Okay, recording has been started. Okay, welcome everybody. We are here at the final presentation, and we have not only our usual group, but obviously our distinguished guests from the faculty committee. So online, we, in addition to our regular troupe, we also have Zoya Kinsler and Takayuki Aida and Sylvain, is it Jalm? Is that how you pronounce your last name? I have not pronounced it yet. Jum. Okay, thank you. And I'm also hoping that we will see Peter Henstock, who said he would be here, and we may also see Eric Geiseke, but I don't see them online yet. Okay. So Joe's Basket did request to go first because, again, Marzina has a meeting that she has to go to, and she'll have to drop off early. So we have 4 very interesting presentations tonight. A couple of these are potentially live projects that a couple of the teams have already decided that maybe they will think about going commercial with these, which would be very interesting to see. And if anybody actually does decide to go commercial with any of these things, or try to do a startup, or try to petition for them inside their company or something like that, we would love to hear about it, because getting that kind of feedback and seeing things go live would be kind of the ultimate piece of greatness coming out of this class for one of these presentations. So with that, let me turn it over to Team 3. And for the faculty committee, if you can just email me comments afterwards on the various teams, since obviously we don't have physical papers that I can hand out for feedback, that would be great. Okay, Joe's Basket team, you are on deck and ready to go.
All right, let's get this show on the road.
You have 20 minutes.
Hello and welcome. My name is John, along with Marjana and Billy. We are Team Customer First. Today, we would like to show you our proposal for Trader Joe's that we'd like to call Joe's Basket. As you may know, we are at the pinnacle of a new grocery market era. Somewhere along the path to purchase, over half of all grocery sales now are influenced by digital technology. This represents an almost doubling in influence year over year, and puts digital grocery shopping on par with well-known long-time digital mainstay categories such as electronics and home. Recent studies suggest that 80% of shoppers have used a digital device to browse or research grocery products. This type of grocery shopping is expected to play an even bigger role in delivering on that experience. But many food-related consumer products companies and their retail partners have yet to take full advantage of that opportunity, potentially leaving money on the table. That's where our team comes in for Trader Joe's grocery store company. We are building next generation capabilities that drive the convergence of a new digital grocery market era. So let's take a quick look at the current Trader Joe's company profile. There is more than 740 stores in the United States that are consistently rated as one of the most ethical companies in the US, and are highly rated by Consumer Reports, which a large presence in the private label market. Value is a concept they take very seriously. However, there are no club programs or cards at this time. Unfortunately, the no clubs concept is an encumbrance for the Gen X shoppers. They prefer to have the ability to utilize technology to aid in making shopping decisions and expediting checkout. Whole Foods is a major competitor, and it was purchased recently back in 2017. And this gives them a huge leg up in the application of technology in the shopping experience. So instead of trying to match technology for technology with Amazon and Whole Foods, we will try to concentrate our savings on the customer's time and helping them with their dietary weight management goals. We must maintain and expand our customer loyalty. Customer loyalty programs and their members tend to be younger than those who aren't members. 71% of 25 to 34-year-olds belong to some kind of store or membership program, and we must cultivate this younger demographic. Now I'd like to hand this over to Marjana to discuss the proposed solution and business process.
Thank you. Our proposed solution, Joe's Basket, will use Trader Joe's data on customer shopping patterns, as well as data that is provided directly by customers simply on their food preferences, health and weight management goals, and time that is devoted by them to food preparation. Based on that data, we will develop a weekly recommended grocery basket that will be provided for customers to purchase. that basket will be available for either store pickup or home delivery. This solution will significantly contribute to developing of a loyalty among customers because of the ease of the grocery shopping that this will provide. Additionally, it's a truly unique solution because while you have other stores providing their customers with an option to purchase grocery online, our weekly grocery basket will be targeted to meet our customers' specific needs, both when it comes to food preferences as well as health and weight management goals. A personalized grocery shopping experience will be developed, as I mentioned, based on the information that is provided by our customers during online registration process. During the registration process, we would ask them a number of questions, including their age, gender, weight, personal fitness goals. Are they into weight training? Are they into running or any other exercises? What are some of their health goals? Are they striving to lower their blood sugar level, cholesterol, and so forth? Any type of food restrictions like allergies, or perhaps food restrictions that are put on them by themselves by choice, such as being vegetarian. Based on that information, we will develop personalized profiles for each of the customers, which would be then applied into our Joe's Basket machine learning algorithms. That machine learning algorithms would allow us to propose a weekly grocery basket, which then customers could pick up at the store or have it delivered home. Mm-hmm. The benefits of this offering are threefold. The one category of benefits is for the customers themselves. Having a weekly grocery basket that is composed for you and is available for pickup will definitely save time and potentially save money. And this was one of the reasons why I'm particularly interested in this type of solution, because I don't like to spend 3 to 5 hours a week shopping for groceries. That amount of time is very meaningful for me, and I would love to have a solution that would allow me to save that time. It's also stress-free and helps to achieve health goals. It's stress-free because you don't have to walk around the store in a crowded space and trying to pick up the food you need for every week, and trying to avoid forgetting items and achieve health goals. That's because the weekly grocery basket will be personalized specifically for you based on your current goals and nutritional profile of each food items. The solution would benefit also each individual store, because our Joe's Basket algorithm would not only match customers' preferences and goals, but it also would match available store inventory to make sure that we reduce the food spoilage and work towards just-in-time inventory model. And lastly, this would definitely benefit Trader Joe enterprise as a whole because of increased customer loyalty, as well as decreased spoilage of food items. So I briefly touched on some of the benefits in the previous slide. Here I want to break down the benefits specifically into financial, customer experience, customer service, and operational excellence. As I alluded previously, Joe's Basket solution would increase store profitability, Trader Joe's profitability, and our goal is to increase that by 5% over the next 12 months. This will be accomplished by growing customer base, by adding new customers due to that program, as well as improving customer retention. Another category of key business objectives is customer experience. And our goal is to demonstrate that our customers are satisfied with the solution and achieve NPS greater than 80. Just for as a frame of reference, Costco is one of the most liked grocery stores, and their NPS is close to 80. And lastly, our goal is to increase market share by 5% points in the next 12 months. On the customer service side, we plan to improve our customer satisfaction over the next 12 months. And finally, we plan to improve operational excellence by reducing food waste by 15% over the next 12 months. This is a representation of how the sign-up process and customer online experience would look like. The first step to participate in Joe's Basket for a customer would be to create an online profile and to complete a registration form. Based on the input provided in the registration form, based on the individual preferences as well as individual shopping pattern, Joe's Basket would provide weekly grocery recommendations. A customer at that point will have an option to either confirm the proposed grocery basket and effectively make a purchase for pickup, or make modifications to our proposal. Now, the modifications are important because this data will be ultimately taken in and used by our machine learning algorithm to improve recommendations in the coming weeks.
All right, and I'd like to talk about a real-life use case. It's a lady named Lisa, who was an IT professional and now a full-time mom. She has 2 young children, 7 and 9 years old, both with food allergies. One child has a severe allergy to peanuts, and the other child is to soy. Lisa spends a lot of time reading ingredients and information on food products, items, to ascertain whether the groceries she purchases are safe for her children. Having a customizable grocery basket service that suits her children's dietary needs will allow Lisa to save time, avoid life-threatening mistakes. And there are many potential customers who have specific food needs. They may be vegetarian, vegan, kosher, halal, or allergic to certain foods. And current procedures do not take advantage of data on the customer shopping patterns and experience, and personal fitness and weight goals and health goals and food preferences. So customers who have signed up for the program can utilize a Joe's Basket mobile platform on the go from just about anywhere. Once they signed into the mobile app, they can view the available food preference options. There are several choices to choose from based on your dietary needs. Whether it may be organic, kosher, vegan, or vegetarian, like I'd mentioned, you can simply select what you are interested in by scrolling down through all the available options. If you or someone in your family has a dietary restriction or food allergy, those can be selected as well, such as no milk, lactose, eggs, fish, crustacean shellfish, tree nuts, peanuts, wheat, glutens, and soybeans. You'll feel better knowing that all 8 of the major food allergens identified by the FDA are able to be excluded. After you have customized and selected all your food preferences, recipe, and meal choices that are automatically recommended to you, you can slide through these recommendations and select any food items that you want to purchase simply by adding them to your cart. When your food selections are completed, you may then set a date and time on your mobile device and when you would like to pick up your groceries. This can be done daily, weekly, bi-weekly, or monthly, allowing your grocery shopping experience to be simple and efficient. Here is an example of a possible use for Joe's Basket as well on the application. Let's say Christian and Ruth are a happy couple. Ruth's parents are planning to visit during the holidays. However, she feels they are not too keen on their daughter seeing someone who doesn't share their beliefs. Chris is very nervous because this will be the first time he meets Ruth's parents. He wants to impress them by surprising them with a delicious dinner. He knows that Ruth's parents are kosher and their food preferences. Krish is not familiar with this very much, so he uses the Joe's Basket app to select kosher food items, meal kits, and recipes. Krish is able to select his food items on a pickup for a specific day, and he's able to have enough time to prepare a surprise kosher dinner and impress Ruth's family. Now I'd like to hand this over to Billy to help explain the back end part of the system.
Billy, are you there?
Sorry, my
Oh, there you go.
mic is on mute. This is the diagram of the backend of the Joe's basket. First, the cloud server will push the tickets to the retail ticket system. The retail ticket system will display the tickets to the staff in the retail store. Based on the time, the store staff will prepare the basket. They put all the food items into the basket, put the label, RFID, and then staple it. The system will check the items that put into the basket are correct by monitoring the changes of the weight of the basket. When the time is up, customer can go to the Joe's basket specific area to get their basket, and then they will line up on the express checkout link with the QR code within the mobile app. The cashier verifies the order, the sealed bags, the bag weight with the QR code in the point of sales area. Then they can happily go home much faster than before. This is the system diagram of the Joe's basket. In the top left corner, you can see the online portal. There's a website and also the mobile app. Customer can refill their orders or request a new recipes of the week. In the center is the enterprise cloud computing. The data analytics system will collect data from 3 different databases: the customer database, inventory database, and the recipe database. The inventory database is reflect to the live inventory of the store, the retail store inventory. So they generate the new recipe of the week or a specific meal to the customer to the app. Once the customer confirm, they will send the orders to the retail store. As I mentioned before, the retail store ticket system will pick up the orders and transfer to the basket ticket to the staff. Keep in mind, we also offer the dashboard for both the headquarters and also the retails. So both the retail manager and the headquarter can see the status of the Joe's baskets as well as the projection, the forecast of the purchase volume. Next.
As Billy mentioned before, the data would be coming from 3 different sources. Let me go in detail over like what type of data we will be collecting and how that data will be then used by our ML model to develop the weekly Joe's basket. So number 1, that would be data provided by a customer, either via online registration form, which would include, as I mentioned previously, customer individual food preferences, as well as fitness goals, age, and so forth. The other type of data would be data about the customer that will be collected by Trader Joe's. What that would include is a customer weekly shopping pattern, amount of money spent, as well as, at this point, amount of time spent at the store. And lastly, the third category of data would include data coming from Trader Joe's inventory system on number of items on hand and the expiration dates. Let's move on. We are planning to use content-based recommender engine for the grocery shopping, where Joe's basket would match a customer and an item profile. A customer profile will be created based on the data provided by a customer, both implicitly and explicitly. And an item profile will be created based on a set of keywords assigned to an item. Customer profile, the explicit type of data would be coming from the registration form, and it would include first name, last name, email address, gender, date of birth, height, weight, food preferences, weight management goals, fitness goals, allergy considerations, health restrictions, family size, grocery budget, amount of time available for meal preparation. Item profile would then include food category. Is that a protein, fruits and vegetables, grains, and so forth. specific nutritional information, which is caloric content, sugar, fat content, sodium, and allergen information. Then customer profile and item profile will be used in our model. What you see in this picture is graphical representation of how we will define our training sets that we will use to fit and tune the model, as well as test sets that would be quote unquote put aside as unseen data to evaluate the model. What we will do, we will pretend that the test data set is a new data where the output values are withheld from the algorithm. Then following that, we will gather predictions from the trained model on the inputs from the test data set and compare them to the withheld output values of the test set. Then we will compare the predictions and withheld outputs of the data set in order to compute performance measure of the model and on the test data set. Having that information, we will be able to evaluate how accurate is our prediction, and that's the feedback loop that you see in this picture. And with that information, we can go back and tune the model. Moving on.
So this is the high-level timeline of the project. The phase 1, we will deploy our Joe's Basket to 5 retail stores on the first 8 months. During these 8 months, we will start to create the data model, do the mobile app, and also the cloud computing. Then after this, everything is ready, then we will have 4 months to review the performance of those 5 sites. Then we have the phase 2 to push the Joe's Basket to nationwide. And the phase 3 is the 8 months. We will try to use the delivery instead of just pickup, and also the kids meal. Next slide, please. Here is the detail of the phase 1 technical development. So there are 3 work streams. First is the Joe's Basket recommender engine model. We collect data, we build profile, and then we create the Joe's Basket step into the recommendation engine model. We also test the model during the development. The second work stream is the online portal and the app, the mobile app. The third one is the physical retail store changes. So we will integrate both the online and the cloud computing together and then test it out. And then at last, we will also integrate the recommender engine model. And then we do the rollout and the evaluation. This is our budget. We break into the 3 buckets in high level. The operation staff, we need to hire 4 engineers, 2 data scientists, and 2 customer supports for the 5 sites. And then we will have the infrastructure, which including the expense of compute, storage, and the network. At last, we need to spend money on in terms of changing the retail stores. We have to ask consultant to integrate the RFID for us. We need to purchase the RFID hardware, computers, and the modification of the express lane. The total investment of the phase 1 is 1.64 million. Let me summarize the project success matrix. What we are measuring is increase the net profit by 1.25%. And also, we want to increase the customer base by 5%. The net promoter score, the NPS, is greater than 80. And we also monitor to make sure that we reduce the food waste by 15%.
Yes. And you see, the traditional brick and mortar retailers, such as Trader Joe's, have serious work ahead of them if they are able to protect their market share in this new digital age. Our collaborative approach with the Joe's Basket digital platform will provide a unique, customized shopping experience tailored to the customer's health and dietary requirements. This will differentiate Trader Joe's from all other online grocery platforms currently on the market today. However, this change will not happen without consistent executive commitment. There is no room for complacency and the business as usual mindset. Our plan will provide a return on investment by improving profitability and plan to increase sales revenue to 10% and expand the number of Trader Joe's customers by 18% in the first 2 years. Cost savings is another benefit, with the decrease in overhead by improving the supply chain processes and reducing food waste and inefficiencies, streamlining merchandising, and improving Trader Joe's overall brand name awareness. The time is nigh because it doesn't matter where you come from, it matters where you're going. Thank you very much. This concludes our presentation. Does anyone have any questions or comments they'd like to share?
Hi, this is Takayuki. I have one, if I may.
Yeah.
Yes.
So with this new system, it sounds like there's going to be sort of a new job that's going to be at Joe's Basket to basically prepare these baskets. What's sort of the operational and IT support that's needed to allow for this? Do they have any new IT systems or something new hires who would be able to do this?
Yes. Our budget incurs that we have set aside for our IT team that will collaborate together, and they're the ones that will be hired and brought on to the team to help fulfill and build this application and the cloud-based platform.
Well, I mean the employees who are going to be preparing the baskets, not the IT staff one.
Oh, yes.
Oh, okay.
We'll be
Let me
training
answer
them.
on that one.
Yes.
Yeah. So in terms of headcount, we calculate the traditional checkout will be about 10 minutes per customer. But with this Joe's Basket, it will down to like 2 to 3 minutes. So that means we are estimated instead of like typical 10 staff in the cashier, we will reduce to be 8 staff for the regular checkout, 1 for the express lane, and then we save 1 staff and put into the warehouse to do the preparing of the basket. So that means also in the document that we say that there's no change of the staff number in the retail store. This is what we try to do in the 5 pilot stores.
Okay, I see. Thank you.
Can I ask? Yeah.
Yeah.
Can I ask a question? No. So why did you pick Apache Mount as the machine learning engine?
It's specifically because of the recommendation model. The Joe's Basket will not be doing recommendations based on what other customers like. It will be doing recommendations based on matching different item profiles. And Mahout offers that specific support for that specific model. In my previous role, I worked on Databricks, which is the company offering Spark as a cloud product. We actually were funded by the founders of Apache Spark. And I'm very familiar with that, but unfortunately, Apache Spark doesn't offer the specific recommendation engine capability that we're looking for.
Okay. Thank you.
Sure.
Hi, this is Eric. I have a question. Have you thought about extending your business model to support delivery, home delivery as well? Could you do that?
Yes, in phase 3. So we want to focus on make sure that we have the specific edge of this service, which is the personal customization of the online shopping first. Once we validate it, we expand to national-wise. At the time of phase 2 to phase 3, we will do the pilot project for delivery and also the kids meal together during the phase 2, phase 3. Yes, the answer is yes.
Okay, thanks.
Right. Peter, if you're being quiet, let me ask my question next. All right. I wanted to ask a question in the area of integration. You're building a beautiful new solution, and oh boy, Trader Joe's could really use this solution because they're famous for not doing customer loyalty programs, and this will introduce a customer loyal or increase their customer loyalty this way. And yet Trader Joe's probably does have a customer database today. At least they do the mailing of brochures. So my question is, are you planning to capitalize on any existing data in the Trader Joe's existing databases when you are instantiating your own Amazon S3 database and where you're building your own customer data? Is there a plan to integrate what exists with what you're building?
Definitely. So that will be part of our investigation phase to see what type of customer data Trader Joe currently has. As you mentioned, they do have a contact information for individual customers, given they do provide promotional materials. But in addition to that, do they have any information on shopping patterns? Maybe they do, maybe they don't. If they do, definitely we would leverage that information. And, we would start, we would probably create 10 to 20 test cases based on the existing data and see accuracy of the recommendation given the data that they have. And then, as we get more input from customers that do sign up online, we can refine that recommendation.
And there's one more thing. We are thinking in the document, we are planning to see if we can harvest the existing historical data by the credit card user. So let's say previously, there's some guy who go to the retail store and purchase. We don't know who he is, but we know that they are using one single credit card. So once that person who joined the Joe's Basket program and then use the first transaction of the Joe's Basket, we can link the unknown to the specific person in order to enhance the machine learning about the preference of their shopping. So that is already in our design, but not in the presentation.
Thank you. And one more question on a different topic. In your architecture, you're planning to have a new interface to push the orders into a certain retail store. How do you determine to what store to send your orders, and what infrastructure modifications? I see you are planning infrastructure upgrades, but I thought that is mostly for handling the RFID tags and new baskets and so on. But from the interface perspective, what is needed to push the order data, what you call a ticket, into an existing store system, POS, I suppose?
So let me try to answer this question. In the customer profile, when they confirm their Joe's Basket, we need to ask by default, is their preference or primary retail store? So the order will, from the enterprise cloud data, will push it to the correct location. Just in case the UI of the app or website allow user to go to another store for whatever reason, maybe on vacation. So they will push to the other store, and if they're nationwide deployment, then we can go there. Or if that is not available, the app will say, I'm not able to confirm your purchase because at that moment, Miami store is not available for Joe's Basket. So that is one of the things that we have to make sure is customized and personalized order. It's not a generic one.
Thank you.
Thanks.
Any further questions?
Yes, this is a really great, ambitious project. I love the whole thing. It's so many different moving parts and all going at the same time, but I guess that's also the challenge. How come you're putting so many things in more or less fairly quickly in terms of a rollout as opposed to more of a gradual rollout of one piece at a time to get the online stuff, the infrastructure behind it, and maybe the recipes a year later or the analytics a couple of years later?
In phase one, that's where we're having a consultation with our certified nutritionists and the food vendors, and we'll determine in that particular time frame in phase one, how we're going to divide and set up the system. And then we have the different phases that we're going to be roll those out in the first phase. There's going to be 5 test sites, and we're going to see how well that goes. And then after that success, we'll go to phase 2, and we can start implementing out nationwide and full functionality. Moving out to phase 3, then we can explore at maybe mobile delivery and such.
Yeah, that was a great question. Really, the recommender engine is the key element of our project, because just simply providing customers with an option to buy grocery online would not deliver the unique value. So we have to develop the engine at the same time as the platform, and developing of the engine itself will be probably the most challenging and time-consuming part of the project, just because this technology is just being tested by companies right now. It's not well-known and well-established technology, but we have to tackle all of them at once.
If you started with 5 different sites, are you worried about preferences being different across the country as you roll it out? Because you'll have basically biased your data for the recommendation engine when you start.
So the preferences will be provided by individual customers. It will be provided by customers in California, as well as customers in Florida, and as part of filling out the online profile. So we will know specifically what customer A likes, and the recommendation will be provided based on that data.
That's right. And the recommender system will be more rolled out towards the later part of phase 2 and phase 3. When we collect, you're right, there will have to a substantial amount of data will need to be collected. When we get that, if it's enough data, when there is enough, we'll see how useful it can be, the development of the recommender system.
But the data is only based on 5 stores though, isn't it?
No, in the beginning, it's just a beta site.
So the reason why we pick 5 store or the 5 specific location of the stores is we are targeting the most high usage of high-tech or mobile usage community. So those are exactly the same one that we think they may more interesting on the personal customized service of grocery shop. So yes, it is a limited data at the beginning, but that is also the primary targets of our audience at the beginning.
Great, thank you. Great system.
Okay, I think Christina had a question.
Yeah, obviously, this is a great idea. You've heard my feedback many, many times, and you are getting my unqualified approval at this point. This is really fantastic. I do have a question. So we see things, oftentimes in the news, or it tends to emerge gradually. Food preferences have a tendency to shift. So, for instance, in Europe, certain allergens are being more widely recognized, like sesame seeds, whereas here in the U.S., it's not even a required labeling for that kind of allergen. Or there'll be a food scare where suddenly people go off of margarine. How will you adapt? What is the plan to adapt the product without getting into so much feature creep that you're addressing 17 different allergens? What are the criteria for adding new modifications to the system based on popularity or legal regulation, or what are the criteria for growing the features that people can put into their food plan?
That's a great question.
That's a great question, and I think that first bar for the criteria would be anything that would potentially have impact on customers' health, and that becomes very relevant when we discussing allergens. And then I think John wanted to address that.
I was just going to say that currently the FDA has 8 food allergens, 8 main food allergens by law that is set up, and that's currently what in our push, that's what we want to address currently. Now it would be great down the road, later phase 4, phase 5, to be able to implement a even more customized, depending on how successful the system is, and once we get the system in place, to add things like the sesame seeds or mustard or any of the other potential allergens. I think the more would be better, and the more we have, the more successful it would be. But you're right, that it would be very challenging to stay upon that. We just kind of want to take our some small steps and get the base system implemented, and we would love to be able to have it set so it can be expanded to include a lot more preferences.
Excellent answer. You guys really are addressing, to some extent, you're turning Trader Joe's into what's a long tail business model of selling niche products, even more so than they are. So the more you can kind of adapt to that before becoming too niche, the better. This is really just great work, though. Great answer.
Okay. I think we've beaten you guys up long enough on this, and we need to move on to the next group now. Outstanding work, guys. The presentation was extremely well done. You handled all the questions with great aplomb. Your answers were spot on. You obviously had thought about this. Very, very nicely done. Congratulations. Applause from the PhD and hopefully from everybody else as well. Okay. Yeah. We always applaud for presentations, guys. Come on. See, when we're doing this live in Zoya's event, then there's always applause. So we just have to do it over the net this time. All right. Let's see. Where's John? Let me drop your co-host. And now we're going to move on to Team 2. Yes, we did have a couple of special requests for ordering tonight. Sorry about that. I know some of you guys were hoping to go in 1, 2, 3, but just because of scheduling, we had to do it this way. Okay, IDSS, you guys are up next. Yes. So who's going to drive your slides?
Greg will be.
Greg? Okay. Okay, while these guys are getting, I don't know why there's a FedEx logo up on my screen right now, but there we go. Okay, interesting. So,
hey, they got to get that out there. Free advertisement.
There.
Oh, there we go.
Cut over now.
Okay, Team 2, the floor is yours. You are ready to go.
Good evening. We are IDSS, Identity Security Solutions, a simply named company with the goal of solving a very complex problem. We are responding to a request from the Massachusetts Credit Union Association to develop and pilot a system to be used by its member institutions that would enable them to better secure and store credit union member personal identity information, also known as PII. Krishna will now give an overview of the problem as we understand it to make sure we're all on the same page.
Hi. Recently, Massachusetts Credit Union Association has experienced numerous online attacks. There is a growing concern about maintaining adequate levels of security of the members' personal identity information. Identity theft is a significant problem in the United States, as the identity theft happens once in every 2 seconds. Data breaches are prohibitively expensive for the financial industry as it impacts the business, customer trust, and reputation. The average cost of a data breach for a financial institution is somewhere around $245 per record loss. Credit unions spend an average of $136,000 per year towards the data security measures. So it is risky and expensive for the credit unions to maintain this information. For loan applicants, there is no privacy control on who is looking into their PII and whom they are sharing with. In addition, the existing manual identity verification system is slow, expensive, prone to human errors, and leaves consumer with a bad user experience. Finally, it's a complex process for regulators to monitor, audit, and control. My colleague Mike will provide the proposed solution.
Given the unique challenges in securing this data, we hope to work with the Credit Union Association to introduce a pilot system for developing and managing a shared, secured, and centralized cloud repository for storing and accessing credit union member PII data. The system should have a user-friendly interface for access by the branch staff. It should have, additionally, a system that includes two-factor authentication for added security, and so that members have better control and insight into when and how their data is used. My colleague Gillian will now talk about some of the business requirements for this project.
Through this pilot, IDSS plans to introduce a new system for storing, securing, and maintaining sensitive identity information for credit union members. The pilot has the following objectives: implement a more secure identity storage system for the loan application process, the ability to provide loan applicants with details on how their identity information was used during different parts of the process, reduced liability of the credit unions with respect to PII, and finally, improved customer data management process.
Krishna?
I'm sorry, I was on mute. Let's see how the proposed system protects the identity and confidentiality of the PII. In the current system, credit union collects the personal identity information, stores them in the local branches. The data gets replicated to the central database hosted in the data center. The problem with this model is it is enough for hackers to compromise data at any single branch. The tampered data gets replicated to the central database, as there is very limited mechanism to validate the authenticity of the replicated updates. In the proposed system, PII data will be distributed across multiple nodes. In order to steal or tamper the PII data, hackers need to gain control over all the nodes instead of a single entry endpoint. This hurdle makes it extremely difficult for hackers to steal or tamper with the personal identity information.
We believe our new system will need a number of key features. Records are to be stored in an ultra-secure, tamper-proof distributed repository. PII data can only be updated at the credit union after being authorized by credit union members. Data should be stored in a cryptographic format. Credit union members' PII is digitally signed using a mutually agreed upon method that allows participating institutions to read but not alter the data without the member's consent. The credit union is able to quickly access the system and retrieve the needed data. Credit unions will need a web-based interface into the IDS PII Vault to request and update any data. The interface will also coordinate customer authentication and authorization of record creation, modification, and access. And finally, the credit union members will have an application on their phone to approve access to the PII.
We expect a number of financial benefits to manifest. There'll be a decreased likelihood of the resulting costs from a data breach, decreased IT costs associated with securely storing customer PII data at multiple member institutions in their branches, decreased regulatory control and compliance costs, increased confidence in credit union by current and potential members. These members will be less likely to switch to other credit unions and more likely to use additional services, resulting in increased revenue overall. Additionally, they will probably refer others to the credit unions as well. These are some of the additional business benefits that we expect to achieve. Reduced liability on an individual credit union with respect to PII. This system will create a shared data security and responsibility model between the credit union and the members. Reduction in data entry errors, as loan applicant identity documentation will be stored digitally from the beginning to the end of the process. Reduction in costs due to paper waste, physical storage, data storage, and backups. An improved reputation of the credit unions. And the transparency of transactions, a reliable platform architecture, and single interface for auditing will help regulators to easily monitor the end-to-end process.
Since this will be a proof of concept pilot, the Mass Credit Union Association has requested that the pilot will be deployed to 100 new loan applicants at 10 different credit union branches over a 6-month period. This timeframe aims to include all stages in the loan process, starting from the initial process of the pre-approval, the final loan approval, and the first few payments of the loan. At this point, IDSS and the credit union will review the process and determine the next steps. The expected outcome. At the end of the pilot, IDSS anticipates achieving a proof of concept of a more secure identity information storage system in use during the loan application process. Additionally, IDSS expects loan applicants to have greater control and transparency into when their data is used and accessed throughout the process. And finally, the storage of PII is not duplicated across multiple financial institutions. After the pilot is complete, IDSS will follow up with pilot participants, including the loan applicants and loan officers, to gather feedback about ease of use and process time. IDSS will also take into consideration applicants that did not finish their loan process to see if the reason for incompletion was due to the new system. IDSS and Massachusetts Credit Union Association will then discuss the outcome of the pilot, potential changes to process, and rollout plan.
At the core of our new system, we will be implementing a private blockchain to secure this data. Our solution will have the following characteristics. It will have protection from hacking or system failure. We want to spread the data across our network, making it harder for the system to be compromised. We want immutability. We want a system that makes it impossible to update existing records by malicious actors. We want to be privacy focused. We want to protect consumer privacy of the PII by disclosing the information only to approved parties. We want to have strong cryptographic security that uses hashing for integrity, encryption for security, and certificates for authentication. We also want a programmatic interface to enforce security instead of relying on human involvement. For these reasons, we plan to introduce a cloud-based data repository that is built on a private blockchain. The system will have a secured web interface, APIs for integration with the individual branches, and a mobile application for branch members to have greater control and transparency as to when and how their data is accessed. Blockchains have been a controversial topic in recent months. Most of the discussion centers around the public blockchains, with discussions on the utility of digital currencies. Private blockchains share many of the same technologies and concepts, but have several key advantages over their much maligned cousins. Primarily, a private blockchain consists of a number of key components. Only known participants can interact with the network. Without access granted to the network through our interface, the data contained within cannot be accessed or altered. The data is stored in a decentralized ledger. This means the data is automatically shared across nodes in the network. We'll have a consensus protocol, which ensures that all nodes agree to a certain state of the system and handles the process of keeping in sync. As it's a controlled environment, they do not require complicated, costly, or inefficient mining procedures for transaction validation. Additionally, since it's a private blockchain, the process of consensus occurs much faster than other blockchain implementations like Bitcoin. Together, these business problems associated with data privacy, security, and information sharing are solved. They build trustworthiness, accountability, and transparency while streamlining business processes and adhering to legal and regulatory constraints. As part of our project, we intend to leverage the open source Hyperledger Fabric framework built on AWS.
Here is a high-level view of the interactions in the solution. Each credit union branch connects to the web application hosted in the cloud via a secure VPN connection. The web application securely interacts with the blockchain nodes in the backend. All the blockchain nodes interact with each other to maintain a consistent version of the distributed ledger, which contains the PII information. Credit union customers interact directly with the IDSS application using a mobile application for authentication and authorization. The regulators can access the application in read-only mode for compliance audits. And this is a deep dive architecture diagram to show the high availability and disaster recovery solution. The cloud is a natural platform choice to host this solution due to the on-demand elasticity, scalability, and global accessibility. IDSS application and the blockchain network are securely hosted in a private subnet to protect from malware and hackers from the internet. Blockchain inherently distributes the PII replicas between multiple nodes across multiple availability zones or data centers. This ensures resilience in case of a natural disaster or a blackout. Fault tolerance is implemented with redundant servers and mirrored storage systems. Here is the process for adding a new PII record to the blockchain. The credit union associate enters the customer identity information into the web application and submits it. The transaction generates a smart contract to insert the PII record into the ledger. The transaction is ordered, broadcasted, and all the peers in the net, all the peer nodes for the consensus. After following a standard consensus process, all the peers approve or agree to commit the new record. A new block is created, and it will be appended to the distributed ledgers. A notification is sent to the web application to confirm the completion of the transaction. Here is a process to retrieve or read the existing PII record from the blockchain. The credit union associate requests the PII of a customer in the IDSS web application. The credit union customer receives a notification on his mobile app to approve the retrieval request. Upon approval, the IDSS application generates a smart contract to read the PII record. The transaction is ordered and the data is read from the blockchain. Logs are updated to reflect the operation for audit purpose, and PII data is delivered to the web application.
We've been talking about a few of the different screens that are in place, and here are a few examples. For the PII data entry screen, it will allow the data to be added to the ledger or to retrieve data from the ledger for eventual updating. We plan on integrating, developing a data retrieval API, which can then be integrated in the current Credit Union Association loan applications form. That way, the loan officer only needs to access the PII data during the moments of the process when it's actually only needed. And lastly, there'll be a regulator review screen, which will indicate which credit union employee accessed whose data and when, and if the credit union member gave approval at that time. The PII Vault mobile application is very simple. You only need to provide two roles. Primarily, when there is a data request through the retrieval API, the credit union member will receive a notification on their phone asking for permission to see their PII data. Additionally, right on the phone, the credit union member will be able to see who accessed their data and when.
Throughout the course of the pilot, we'll be working closely with the credit union teams to ensure a smooth rollout. Both the IDSS and credit unions will have project management staff to oversee the work. On the IDS side, our project managers work closely with our development teams to make sure the system is developed on time, within budget, and within the scope of the pilot. They will also oversee efforts to develop the IDS system customer service teams who will support the systems during the rollout and throughout the duration of the program. On the credit union side, PM teams work closely with branch management to coordinate integration efforts with branch IT managers and staff. They will also oversee the branch staff who will be participating in the pilot as they enroll the members, access and update data in the repository, and field member questions. Both PM teams will prepare regular reporting to IDSS and MCUA management regarding the status of the project. Both teams will have security staff to ensure that all best practices are followed in securing the systems throughout development and during the duration of the pilot. They will also work to monitor and respond to potential threats. Finally, both teams will have compliance staff who will work together to make sure that the system is compliant with all applicable regulations and laws. They will also assist regulators with any inquiries that they may have regarding the system or the data contained within it.
Before the pilot rollout, the new system will be tested over several key aspects: functional testing, user acceptance testing, stress and security testing. This testing will ensure that the system functions as expected, it is secure, and the overall system is extendable as new bank locations are added to the network. Additionally, we will utilize penetration testing tools and techniques throughout the development and testing process to ensure that our system is secure.
As part of rollout, we will communicate to the release schedule, take approvals from the stakeholders, procure the infrastructure, and sign up the service contract with the vendors. We will install the development and production environment and set up DevOps, CI/CD delivery pipelines. We also implement the configuration management process for the code, artifacts, and documentation. In addition, we'll set up mechanisms for safe rollback in case of problems after a production release. To ensure operational readiness, we'll implement the change management process and service desk for management of incidents, events, and problems. We'll set up secure isolation on strong encryption to protect data in transit, data in use, and data at rest. Additionally, we'll implement secure access control, identity management, single sign-on with multi-factor authentication, service accounts with digitally vaulted passwords, and separation of duties. Finally, service levels will be maintained for system availability as well as system response time as well as network throughput.
In order to ensure a smooth transition to the new system, training will be provided to credit union employees and the IDSS support team. As part of the rollout, The credit union branch employees will be trained on system functionality and usage. For example, how to perform ID verifications using the system, and how to enter their member and how to help their members enroll in the two-factor authentication system. We will also maintain a support team managed by our customer service manager. Finally, training manuals and quick start guides will be developed for use by the support team.
This timeline highlights the key stages in the rollout, starting from the requirement stage and ending with the full program rollout. The requirement stage is planned to start at the beginning of June. The duration of it is 2 months. The next stage will be development and will last 6 months. It will be followed by 2 months of testing, then 1 month of staff training. The pilot will kick off on May 2019 and will last for 6 months. Once the pilot is finished, IDSS will collect feedback and metrics analysis for a week. This stage will be followed by adjustment and implementation that will last for 1 month. The full program rollout is then scheduled to follow adjustments and will start on December 2019. At the end of the first stage of the loan application process, loan applicants and participating staff will fill out a questionnaire that captures feedback about ease of use and process time. Additionally, IDSS will collect feedback from loan applicants who did not finish the application process to determine whether any users found the solution a barrier for completing their applications. Additional metrics such as system errors, denied requests to PII data, security incidents, and customer support issues will be collected via app analytics throughout the pilot and analyzed during the post-pilot period. The criteria for a successful pilot outcome includes the following. None of the unfinished applications were due to failures in the new process. Overall positive feedback from majority of loan applicants, loan officers, and other participating staff. Minimal number of system or network errors, no more than 2 errors in a week. A reasonable amount of support issues, no more than 5 support issues a week. No confidential data loss caused by security breaches. And finally, implementation of the new technology does not create delays in the loan process. IDSS and the Massachusetts Credit Union Association will then review the outcome of the pilot. If the pilot is acknowledged as successful, the team will develop a plan to implement potential changes to the process based on feedback received, and any other enhancement deemed as needed to improve the process based on errors and incidents raised during the pilot. Afterwards, the rollout plan for the rest of the credit union branches will be established. Finally, while this program focused on securing just the PII data collected from the loan application process, this technology could be integrated across the various banking systems in use by the members of the Mass Credit Union Association. A follow-up with the future planning of this integration will be discussed within 1 year of the program rollout. We'd be happy to take any of your questions now.
Okay. Any questions for these folks? Nicely done, by the way.
Yeah, let me start with the very simple clarification question. In your architecture slides, you were suggesting that there would be a new contract instantiated every time there is a read PII transaction. Why is that necessary? Smart, yes, this slide exactly, the other one. Yes, smart contract is generated when you need to retrieve the identity. Why are you treating it as a new instance of a contract as opposed to just a transaction against existing contract?
The reason why we are referring to it as a generation of a smart contract is because we are planning on tracking and confirming the identity of the person who is making the request against our access list, as well as tracking who is performing that operation.
So the rules to identify the person, the user who is accessing the system will be embedded in the contract? Is that what is the relationship between generation of a contract and the check of the identity of a user and the user entitlements?
It's so that each each time we're checking the information that's contained within the blockchain, we're essentially adding a new element to the blockchain for being able to kind of maintain a log of when and who looked at that data.
All right.
So it follows a similar process to when we're adding data initially to the system.
Okay. Zoe, did you get your answer?
Yes.
Okay. I have a question about so the information that goes into the blockchain that contains the PII information, that's going to be encrypted. Is that right?
Yes.
Okay. So one question about that is generally the encryption keys, I think for like PCI and I think maybe PII too, the standard procedure is to roll the encryption keys periodically, so that if if the encryption key is compromised somehow, the compromise will only last as long as that key is valid. But if you're putting the encrypted records into the blockchain, that they're there indefinitely, and so they would be there available for somebody to use an old key to decrypt. So have you thought about that, and if so, what's your solution?
It's not something that we've directly looked into, but obviously we would design the system in a way that's compliant with all applicable regulations. I don't think PCI applies to the work that we're doing here, but we would, I guess, work within, as we develop our architecture, to integrate some way to kind of remain compliant to those regulations, either by like adding another level of encryption before the block can be accessed.
Yeah, well, I know that other people are doing stuff like this, putting secure information into blockchains, and I just wonder if maybe there's a solution to that problem of how to roll the keys, or maybe having double encryption or something. But it's an interesting problem.
Sure.
Okay, thank you.
Thanks.
Let me follow up on Eric's question. I have just a follow up to what Eric was talking about. It is an interesting problem, and it is a very much needed and interesting approach to handling private information, to putting it, saving it on a blockchain ledger. But the two-factor authentication you're proposing would work if a user literally logs into the ledger. What if there are multiple applications that would be using APIs to integrate with the customer data, right? How many banking applications use customer data today? So what is your solution in lieu of two-factor authentication? If it's not a user, if it's an app accessing the ledger to just get some data, what are you going to do in lieu of multi-factor?
The users, typically the customers or the credit union associates, will use the multi-factor authentication for getting into the system.
Yes.
But all the other transactions will be handled through the service accounts, which will fetch the passwords from the digitally vaulted digital vaults. So all the backend transactions will be handled through service accounts. So they will have the the user ID and password stored in the cyber vault or something like that. So whenever they want to access, they programmatically fetch the password, accessing kind of thing.
Yeah. I'm glad. Thank you for this clarification, because in the paper I'm reading that both APIs and users would have the multi-factor available to them. This is a good clarification. Thank you.
When I first saw the application as going for a credit union, I was thinking you're going to put all your transactions of the finances in there, but you're using it for security. So why did you actually choose the credit unions for that purpose?
I think we wanted to focus on credit unions because, generally they're smaller institutions. They have less sophisticated IT staffs, tighter, cost constraints. So the idea of having a kind of a shared repository was attractive. And credit unions typically organize themselves already in kind of collectives or organizations, and they share a lot of resources. Maybe you can go to other credit unions and use their ATMs. So I think they were kind of an attractive target for implementing a system like this.
Since credit unions are very member focused, they consider themselves owned by their members, we figured that identity security would really aid and enforce that thought process versus a commercial bank, which would probably use this initially as a way to up fees.
I have a question regarding a integration. So, what are the systems in the currently that they have personally identifiable information, like CRMs or such, that they have to have that personally identifiable information, and what's the plan to sort of modify those in order to get rid of their personally identifiable information and instead have them pull from this new system?
I think at least initially the system would only be focused on new credit applications. So it would be, obviously the credit unions would still have their legacy systems, but I think the idea is that new members would use this system, and we wouldn't need to store this data in the kind of legacy credit union systems. And obviously we could explore ideas for further integration. If we wanted to bring existing customers into kind of the system in the future.
But even if it's a new accounts, you still have old systems, right? So have, say, an older CRM system, and you bring a new customer on board, and you put them into this Hyperledger system. How does the CRM then get the information on this new customer, or does it need to?
I think it's Greg, I don't know if you want to take that, but I think the idea is that the key personally identifiable information isn't something that the bank needs to store once the bank knows that you're an authenticated user, like a real person, essentially. So, that happens when the first trusted branch you go into says, okay, Mike Law is who he says he is. I've checked all of his IDs. We're comfortable with his ID. And then in the future, if you were to go to, branch 2, they see that branch 1 has already signed off on it. They don't need to add all of the kind of like raw data into their own system. They can just, and I think that like you mentioned, there would need to be some IT integration on their end to, if those fields are required for their systems to operate or whatever, to do some modification there. But I think the idea is that the data itself, once the person has been authenticated, doesn't actually have to be maintained locally.
Okay, yeah. So you're expecting the individual branches to sort of take care of it via your API somehow. It's not in your scope.
Right.
Right. Okay. We will be providing documentation and integration support during the initial rollout period for the loan application initially. And if it goes well, we would plan on expanding that.
Okay, thank you.
Quick question on testing. You have a very nice test plan, and you've covered all the bases in the area of operational readiness. When someone plans a test, then you have to line up your environments, because you're thinking of a private cloud environment, and then probably you will have a pilot customer with their own systems and their own pilot customer users. What will you use for your Hyperledger environment for testing as opposed to production?
We'll be planning on a smaller scale cloud implementation. While we will bring in external people for user acceptance testing, we will be supplying them with false IDs, fake, not false, made up, created IDs for the process of the testing period, in case the worst was to happen during our testing period before we had fully secured the environment down. I hope that answered your question.
Well, I actually wanted to hear about your testnet instance.
It'll be very similar to our prod structure. It will not be distributed across multiple zones due to cost reasons. When we expand to doing performance testing is when we will start exercising across multiple zones with the planned intention to wipe any data generated during that performance testing period before going live.
Yeah, thank you.
Okay, anything further? Okay. Thanks very much, guys.
Thank you.
You are now complete.
Thanks.
I hope it feels good. Need to hear more applause out there. Come on, guys. You can applaud for yourself. Okay. Team 1, Axiom Health. Who is driving for you guys?
That would be me.
Is that? Oh, okay.
I think I can already grab it. Let me.
Okay.
Let me share this.
Where are you? Let's just while you guys are getting set up, let's do like a 5-minute break so that people can get up and stretch.
Okay.
And then we will come back. It's now 6:55, so we'll come back at 1700 or 1900. So take 5, and we'll get back to the next group. Okay, I'm presuming that everybody is back. It's now 7:01. All right. Team 1, if you are ready, take it away.
Yes. Okay.
Okay.
Hi, this is Axiom Health. Oki, Damon, Azim, and myself are glad to present to you on this day. We're going to go over our business problem today, our proposed process, some financial estimates, technological aspects, deployment strategies, and then we'll open it up for questions. But first, a little bit about us. Our team prides itself on being an advanced technology firm. We strive continuously to improve health outcomes and save lives by delivering real-time insights to healthcare providers and patients. Next slide, please. Ascension is the largest nonprofit healthcare system in the United States. So our clients is the Ascension Health value community outreach and personalized healthcare. But when we think of personalization, it triggers in our minds increased costs, but that couldn't be farther from the truth. And the reason for that is the issue that surrounds healthcare today. The statistics for diabetes are absolutely shocking. Close to 500,000 diabetic patients are admitted to hospitals in the US each year. After those 500,000 patients are discharged, 97,000 of them are readmitted within the next 30 days of being discharged. But why should Ascension Health care about diabetes now, and what does that have to do with decreasing costs and personalized healthcare? Next slide, please. Well, each diabetic readmission costs Ascension Health $7,000. So specifically, for Ascension Health, 21,000 patients are readmitted within 30 days of being discharged, and that costs them more than $150 million a year. Now, this huge figure does two things. Number one, it reflects badly on the quality of healthcare that is delivered by Ascension Health. And number two, it shows that there is a dire need and a great potential to reduce costs by only focusing on type 2 diabetic readmissions. Despite these statistics, next slide, please. Despite these statistics, though, the current process for discharging diabetic patients is quite minimal. Patients at Ascension Health are handed hospital and at-home checklists with various suggestions and information that they might or might not pay attention to when they leave the facilities. And this current process severely underestimates the importance of post-discharge care for the patients. And when they look at the checklists that are provided to them that are not even tailored to their specific needs, they might even not read it, much less follow it when they get home. And many of them might not even understand the information that is being provided to them because of various factors that come into play, such as, say, language barrier or literacy level, so on and so forth. So to rectify this current process, it's important to understand who is at risk. This would be our first and most important part of the efforts to reduce readmission, expanding knowledge and understanding what we're dealing with before we try to solve the problem. So who are these highest risk patients for readmission? Well, for starters, they belong in the category of type 2 diabetes. The reason for that is that type 2 diabetics are not born with the disease like type 1 diabetics are, and so therefore they might lack the basic survival skills that they need to cope with the disease after they leave the facilities. And this is where personalization really comes in. So for this purpose, we want to develop the iPatient platform that we'll explain in detail during this presentation. Next slide, please. Well, we firmly believe that our proposed solution will result in meeting our 3 key objectives for this particular proposal. And those 3 objectives are, number 1, improving the quality of care and decreasing the post-admission morbidity by 30%. Number 2, gathering community data and increasing patients' compliance to their care plans by 20%. And number 3, to eventually reduce diabetic readmission and to maximize the value of medical treatments at Ascension Health. And Azim will now cover our proposed solution that will help us reach these three particular objectives.
Thank you, Sue. Our proposed solution will identify the top risk factors associated with readmissions for diabetic patients. It will draw correlations between those top risk factors and how likely they are to lead to readmission. It will coordinate care across all the patient's medical providers to make sure that pertinent medical information is accounted for. And the biggest part of our solution is the post-discharge support. Too many patients are unsure of the steps and precautions they need to take care of themselves to keep themselves healthy. Patients with chronic comorbidities such as diabetes need post-discharge follow-ups to ensure that their health is within safe levels and so that they know how to stay that way. Our success metrics. A reduction in readmission for diabetic patients would be a great sign, but our ultimate goal is to reduce the diabetic readmission rate to around 14% so that it is in line with the average for all patients. We would also want to see a decrease in cost for our client hospital by reducing the out-of-pocket costs that they must pay when dealing with readmission. Our proposal. We propose presenting every diabetic patient a consent form when they check in so that they can decide whether they would like their data used to provide a more customized experience or not. If they agree to the consent form, they will be presented a self-assessment survey where they can input information that is not readily available, such as their social care network and various lifestyle factors like physical activity, mood, and what they eat. We will also be able to reach out to other medical providers to get their complete medical history and see what has been done in the past and the associated outcomes with those actions. After gathering all this information, we will feed it to the iPatient platform, which will then use the Smart Care engine to present to doctors and other medical professionals with suggested personalized care plans. It will then be up to the medical team to decide what is suitable or not for that patient and deliver a truly custom plan designed for that patient to succeed. The iPatient platform will continue to monitor patients once they have left the facility through the use of a mobile application. We will have access to their physical activity, travel, and blood glucose levels. We can then continuously feed in actions taken by the patient and their associated health outcomes to determine if more intervention is needed or not. Meet Todd. Todd is a 48-year-old male with type 2 diabetes. He came into the doctor's office complaining of a frozen shoulder, which is common among diabetics. When Todd first enters the doctor's office, he is asked to fill in the normal paperwork that everyone fills in when they come to the doctor, and indicates that he's a diabetic. The receptionist sees that he is a diabetic and asks Todd if he would be interested in joining Axiom Health's program for a customized care plan tailored for him. When Todd says yes, the receptionist hands Todd an iPad, which presents the Axiom Health consent form and informs him of what data is needed and how it is used. If he agrees to the consent form, he will be taken to Axiom Health survey, where he can input data that would not regularly be found in medical charts, so that we can get a better picture of who Todd is as a person. When Todd is done with the survey, all his information is sent to Axiom Health's central data repository, where it is analyzed by a Smart Care engine that begins forming connections between who Todd is and what the best care plan for him is. All of this happens within the 10 to 15 minutes that Todd spends with the nurse and is sent directly to the doctor's office. When the doctor comes in and pulls up Todd's file, he will find the recommended care plan and can then use that in combination with his medical knowledge to suggest a care plan that is designed for Todd to succeed. After the doctor is done, Todd then sees the receptionist or hospital aide who will help set up the Axiom Health application on his smartphone so that we can get real-time updates on what Todd is doing and how it is affecting his health. If Todd forgets to do something, such as log his food, the app will give him constant reminders to do so. If he still fails to log his activities, it will send an alert to his doctor with a suggestion that he should have more hands-on care. Next slide. In order for the iPatient platform to succeed, we need a strong analytical foundation to drive the recommended care plans that are suggested to the medical teams. In order to acquire our baseline data, we will be collecting all the medical history of Ascension Health's past diabetic patients. We will then have a team of doctors and analysts that will sift through the data and help form the initial connections as to what care plan should be suggested for what conditions. In order to test the machine learning, we will have to split the data into two sets. We will randomly assign 80% of the patient records to a trained set and 20% to a test set. We will store the trained set in our data repository and the associated connections and run it against the test set to see what the recommended care plans are. Seeing how close the suggested care plans are to what was actually suggested should give us a good indication of the error rate. After we are confident in a low error rate, we'll run the iPatient platform in parallel with the standard process to see if the suggested care plans offer a similar or better plan to what the doctor would offer. After all the QA checks are done, we are ready for the iPatient platform to go live. Now Damien will talk about the technical aspects of iPatient.
Thanks, Azim. So the iPatient platform consists of a data repository, a machine learning engine, the patient consent application, the intake questionnaire, a healthcare provider dashboard, and a patient-facing mobile app. Now, even though the platform seems complicated, it can be understood to have four main functions: data acquisition, data processing, data presentation, and data feedback. The system essentially forms a real-time OODA loop. Now, OODA is simply a military term that stands for observes, orients, decides, and acts. That is, the iPatient platform observes the patient's behavior, orients itself to the patient's data based on rules, then decides the best course of action based on past outcomes, and then acts to send updates to the care team and patient. The cycle goes on and on as real-time information is continuously being streamed into the system. You see, the patient's data is transmitted from function to function to produce outcomes both beneficial to the patient and the provider. Now, the heart of the iPatient system is the analytical engine. It consists of a data repository, a machine learning engine, and a messaging engine, all hosted on the AWS cloud platform. As data is streamed real-time into the analytical engine from the IoT gateway, the platform is constantly looking for changing conditions in the patient's well-being and behaviors. Should the engine detect non-compliance in blood sugar monitoring, activity, or diet, it will generate notifications to the care team through Amazon SNS about the optimal compensating care plan activities to make up for any deficiency. Now, these could range from prescribing a personal trainer if activity is low, to a nutritionalist if the patient's diet is poor, or even virtual checkups if the patient is missing scheduled in-person appointments. Healthcare professionals are engaged and notified when a care plan could be improved. Analysts will look for correlations between care plan activities and outcomes. Now, these correlations will be codified in AWS SageMaker, a machine learning platform. So over time, the system becomes better at tailoring care plans to the patient's individual needs. Now, before a patient can be enrolled in the system, we feel it's important they're educated about the system using an online curriculum to make sure they understand how their data is collected, used, and protected. The e-learning system presents in an engaging manner what iPatient collects, how the platform uses their data, and steps we Axim Health take to protect their privacy. At the end of each section, they are quizzed to make sure they understand the implications of enrolling in the iPatient platform. In today's information management landscape, we feel it's imperative that patients understand that we take their privacy seriously. So once they consent, they are then forwarded to a patient diagnostic questionnaire. Now, the diagnostic collects data on the patient's ability to monitor their blood sugar, what type of care network they have, and how much activity they partake in, eating habits, and also even beliefs about their situation. All of this data is then fed into the analytical engine along with their electronic medical records to generate an initial care plan that is optimized for the patient's situation. Now, the data related to the patient comes from several devices. The patient can use a combination of IoT devices and a smartphone application to passively and actively interact with the system. The iPatient mobile application has a daily checklist of activities the patient is expected to complete. The patient can log their food intake and check off other activities that are part of the care plan. The smartphone GPS and SmartBand work together to determine activity levels the patient is engaged in. The wristband can also monitor heart rate and EKG, body temperature, and blood oxygen levels. The iPatient blood glucose monitor attaches to the phone so the patient can collect their blood glucose level directly in the iPatient app. So we found in our research that accurate blood sugar data is vital in determining the appropriate amount of care for any given patient. The data from the wristband and the blood glucose monitor is then sent to the iPatient mobile application, and then from the mobile application to the iPatient analytical engine. The mobile app and the analytical engine work together to collect data and report results to the patient in a convenient manner. By looking for and alerting of exceptions, the iPatient platform enables healthcare providers to spend their time where it will provide maximum value. Now Oki will discuss our implementation details.
Thank you, Damon. At high level, the overall development will take 18 months. The first 12 months will be our work of developing the software, and the last 6 months will be for training, rollout, and system tuning, as there will be multiple systems interfacing with our iPatient ecosystem. A full rollout of iPatient program to all 153 Extension Health hospitals will take additional 48 months up to piloting at initial location. Then we will dedicate 90 days for stabilization period to make sure any issues will be quickly addressed and continue to closely monitor the performance of iPatient. Post-deployment will also include success matrix. Any noticeable reduction in type 2 diabetes remission will be considered a success. XM Health expects to reduce the rate of readmission by 10% up to the first year and by 45% up to 5 years. Next slide, please. The first phase will configure Amazon Web Services platform and deploy software component to the cloud. The second phase will work on setting up the dashboard, give access to healthcare provider, data collections, data mine thousands of readmission cases related to diabetes type 2, and then develop models that will be integrated into the overall workflow. This includes iterative process for the learning cycle to constantly improve the analysis. Third phase will go into system testing, such as integration, regression, performance testing, security penetration testing, then user acceptance testing. Lastly, we will enroll the patient, set up patient diagnostic. We will also help train healthcare provider on patient enrollment. This is the phase where the iPatient platform is delivered to the users. Next slide. Resource needed for implementations. Since we are using data analytic platform, we will need data analysts to set up analytical platform models and enter initial data. We will need software developer to create iPatient platform. We will need key stakeholder from both XM staff and Extension staff. From XM, we will need account executives, project managers, technicians, and trainers. From Extension, we need administrators, IT team, acceptance testers, and health professionals. Lastly, we will need testing team to make sure iPatient system meet customers' security and performance requirements. Next slide. Initial iPatient development costs are estimated to be $5 million. Each hospital brought online will incur a setup cost of $50,000. Since the program will utilize resources for each patient, a per enrollee setup fee of $550 will cover incremental costs. As more Extension Health hospitals come online and the care plan algorithms become more advanced, we expect the net savings to be increased exponentially. XM Health estimates the net cash flow will become positive in year 4. The total 6-year saving of the program is estimated to be about $6.8 million. Next slide. So we are very excited about this business idea and believe this solution can deliver substantial return on investment. Rate of admission for type 2 diabetes are high. Costs incurred due to readmission are high. We think there is opportunity to justify the business need to cut costs by utilizing emerging technology to analyze the data that can tell stories, improve the process, enhance better service support, and greatly help cut costs. This concludes our presentation. At this time, we welcome any feedbacks and questions you may have. Thank you.
Nice job, guys. All right. Any questions for these folks?
Great, no questions.
I have a question.
Okay, go ahead, Eric.
Okay, thanks. So, yeah, so It sounds like there's going to be some mobile devices that need to be integrated. Are you guys doing the integration, or that could be complicated because there's lots of different types of devices, and so have you thought about how you're going to handle that integration?
Yeah. So we plan to support iOS and Android. So in our paper, we talk about if you're not a smartphone user, this may not be the program for you. But we'll use frameworks like Reactive Mobile or even Ionic, where we can write the application once and then deploy to, compile to the native and then deploy through either the Google Play Store or the App Store. It's kind of the plan.
Okay, and just follow-on question to that: who pays for the mobile device? So patients are using their own phone and just download your application onto it?
That's correct. We didn't mention it in the presentation, but in the paper, there's $100 per year cost to stay in the program. So that covers, any incremental costs to support patients within the program.
And in your summary, you mentioned that the benefits would be lower cost or cost savings, but what about improved health of the patients? Is that also a benefit?
We hope so. We hope it's win-win for both Axiom and the patients. So,
okay, good to hear. Thank you.
Sure, I'll have a shot. There seems to be a ton of data collection and all sorts of great stuff on the input. The output side, as you described it, it seemed to be fairly sparse, as I understood it, in that it was a recommending a nutritionist, exercise, and fairly broad things. Why so general at that side, and can you make it more specific and tuned and understand the intervention effects better?
I'll take a shot at this. So the output it's actually more granular than just a nutritionist or exercise. We'd have a suggested care plan to the doctor, such as like what medicine they should take, or if there's some other intervention they should be taking. And it's up to the doctor to decide if that's the correct course of action for them or not. And then it's a post-care discharge or post-care follow-up, where like if the patient isn't following what they've been told to do, that's when we have more hands-on approaches, such as like making them like go see a nutritionist or having a home aid nurse come to their house.
Great. The idea of recommending medicines are probably a pretty dangerous area. That you're going to have a whole lot of other people who get involved in that, from insurance companies and even the FDA, perhaps. Have you thought about how to handle that?
Well, I think the thought is that we would, so let's say my mom's a type 2 diabetic, and she's done a really good job of managing her blood sugar, and they can tell that by looking at long-term A1C values and where those are. And so our thought is by monitoring blood sugar, you're going to get referred to somebody. It's not going to say up your medication or you need to be on this medication. It's going to be like, oh, this person's blood sugar is really wavering and they're overweight and they're not participating in any physical activity. We need to refer them to a medical professional. And if they don't follow up, then we'll send the medical professional to them. It'll just keep escalating until the compensating activities are sufficient to reduce the likelihood of readmissions.
Thank you.
I have a question regarding your analytical part of the project. Do you plan to, once you collect this raw data from patients, from the enrolled patients, you'll be sitting on very good data. What other data do you think you need to be able to analyze and produce recommendations? Are you planning to use any external third-party data to subscribe your system to any other data flow?
Well, we're going to be looking at the community resources, things like community resources that patients might have access to, and the kind of support system that they have at home and just their basic environment, like what their literacy level is and how well can they understand the instructions that are given to them. And so all of these factors combined with the monitoring that we'll do using our devices is all taken into consideration.
And where do you plan to obtain that data?
During the hospital, before they get discharged. So all of these questions are going to be considered before they leave the facilities.
So the surveys again, and you will be learning from your own collected data through the surveys and monitoring. No external published or purchased third-party analytical data is required, right?
Yeah, at this point, I don't think we know of any correlations that we could make. We could always add a data set to the platform if we needed to. But at the present time, we think between the self-reported health support care that the patient has and their medical records, that will give us a good start along with the passive monitoring and active monitoring. So we'd start there.
Okay, thank you.
Anything further? Okay, one quick PHB question here. Who's footing the cost for all of the various devices that are being incurred here? You have the pulse oximetry, the blood pressure monitors, and so forth. And where's that coming from? Is that being billed back to the patient's insurance, or do they have to buy those on their own, or where's that coming from?
I think our thought is that's in the enrollment fee. So we looked at Toshiba has a new health analytical chipset that's fairly economical that does all the stuff I mentioned. And so we think we probably could produce a bracelet for, don't make me give a number, but we think we could fit it into the enrollment cost. Of course, if they lose that or need to purchase a new one, then that would be billed back.
Okay. So you're talking about creating your own medical device. Have you even considered the problem of FDA registration and testing?
Well, no. This is a Toshiba device that exists, so
Okay.
we aren't creating a new device.
Okay, it
It's
sounded
pretty
like
new,
you
though. It's pretty new, so it's cutting edge. I don't know if it's been FDA approved yet, but it was definitely an interesting thing we learned about. So.
Yeah. I have a question following up on technical conversations and data conversations. Let's go back to the business plan, business model. It is a nonprofit organization, Axiom. The relationship, the main customer is the patient. You will be surveying patients, collecting their data. In your architecture diagrams, you're showing that there will be a relationship established with the doctor's offices, with the providers, hospitals and such. So what is the business plan for this relationship, for the relationship with the patient's doctor? You're saying you might refer to a provider, you might collect the health records from a provider. What is the business rationale and plan for building this relationship? How do you plan to do that?
Yeah. Axiom, I mean, anyone else want to take it? All right. I'm just doing a lot of talking.
Answering all questions.
I know. I'm like, this is fun. Let's keep going. So the interesting thing about Axiom Health, they are the largest healthcare provider in the United States. And, they have, we're kind of making assumptions that their doctors will be in the Ascension Health network, and so they would have access to all of the medical records. So that relationship would already be there. I actually had back surgery not too long ago, and I saw another doctor in the network where I had back surgery, and he's like, "Oh, I see you had back surgery," and he could read the chart and understand what was going on. So we're kind of taking that for granted, but I think it's a pretty safe assumption just based on the size of Ascension Health.
So then, if that's the case, if the relationship isn't the problem, there's enough incentive, you treat doctors as basically an employee of the organization, fine. Is there a need for a technical interface into the doctor's systems, or is the assumption that the doctors already are all registered on the Axiom Health software platforms?
Yeah, I mean, we're assuming we're in their medical record system, so it's transparent to them. They wouldn't have to install anything new to see the information that we're integrating bidirectional into the EHR systems that Ascension Health has.
Thank you.
Okay, I think Christina has a question, and then we'll have to move on.
Yeah, a really quick one. You really do a good job of illustrating the breakpoint where this starts to deliver some real ROI. You know, we all know that models can often be very optimistic. Is there, given that you're also improving patient outcomes and there are financial consequences for not improving patient outcomes, but of course, obviously life consequences as well, if this doesn't deliver the expected ROI, first of all, how optimistic do you feel that that projection is? And B, how reduced does the ROI have to be off of those optimistic projections before you decide that the project is not worthwhile, given that it's also improving patient outcomes?
A tough ethical question.
I know what I would say. I'm talking a lot. Team, come on, jump in. I mean, I think that's up to, oh, go ahead, Oki.
Yeah, I think our goal is 10% to reduce emission by 10% the first year, and then 45 up to 5 years. I think we kind of have to gauge this as we go. There's no hard liner to stop the project, so to speak, unless there's a black swan you know, event, then we need to reevaluate the situation. But I think we would move forward.
Yeah, really, as the vendor, I think it's the onus is on Ascension Health to decide if, even if it wasn't making money, if it was providing better health outcomes, if that was worth it, simply based on that.
Yeah, the indirect benefits might be worthwhile to Ascension to keep the program running.
I think it's also the patient education that we're providing. So there's a big percentage of type 2 diabetic patients who don't even know, like, don't even have the basic survival skills, and so that plays a lot into finding value in that thing alone. And I think like how Oki said, that if we reduce readmission by only 10% from the high-risk patients, it's going to save Ascension Health around $15 million a year.
So I think it's Extension, right? Who's our customer is going to make the call, to be honest with you. We are the vendor. We provide support. So
yeah, that would be my assumption too.
Correct.
Yeah. Okay, guys, nice job. You are now done. Congratulations. All right. Okay, so we're down to the last team now. Sarah, are you guys ready to go? And who's driving your slides?
Yeah, I'm ready to go. If you can hear me, this is Greg. I will be driving.
Okay, got it. You guys get to bat cleanup here.
All right. Save the best for last, right?
There we go.
Okay. All right. Let's see if I can share. All right. Can you see that now?
That's just coming up. And we have a new team. We have a new faculty member here who's just joined to help evaluate your process.
All right.
Okay, you guys are up.
We'll try to make it perfect.
Ah, oh, very good.
Bad. All right.
Hello, we are an IT solutions team within Google that is charged with applying analytics to large amounts of available systems operational data to better manage the infrastructure and applications. On average, more than 20,000 incident records and 600 gigabytes of machine data are generated daily within Google. The overwhelming majority of this data stays dark and is never put to any productive use.
So here's what we know. Data centers generate a lot of data, and this data often exists in silos within the organization. Systems failures and outages will happen even to the very well architected systems. Outages are expensive, and according to IHS Markit Limited, a global information provider, North American companies lose about $700 billion a year to IT outages. So, how do we use the data at our disposal? Available data center resources and lessons learned from past experience to rapidly take action aimed at minimizing the impact of outages or data center incidents when they occur.
Google Enterprise System Incident Records are generated from automation or customers and are then assigned to first-level teams. The first-level analysts are trained to search through knowledge bases for potential solutions before beginning any initial troubleshooting. But what is often the case is that new hires, or really anyone who should initially own the incident, may avoid ownership, and this usually comes down to a lack of experience, or sometimes they'll even peek into the record looking for available documentation, and when they don't find it, they can be intimidated to own the record. This delays the start of recovery, and quite often a higher skilled analyst time is taken up with basic support tasks. Once a record is owned, it then takes significant time to gather more related details and analyze the state of the environment before attempting to remediate. Also, when first-level teams don't have the necessary skill sets or documentation to properly diagnose an issue, they must escalate the record to another team. Escalation can occur several times throughout the event, and this requires a large amount of communications between different teams working on an issue, just to understand previous diagnostics. So to solve this problem, we propose to build a platform that will integrate with Remedy, our incident management application suite, as well as additional existing machine data sources. The new system will assist first-level support teams with diagnosing issues by analyzing data in real time to recommend classifications for root cause, solution documentation, and escalation contacts. Historical incident fields will provide the initial taxonomy for all classifications, and additional data sources will be integrated over time to improve the results. Using a machine learning feedback loop will ensure that as more data is collected, the system will provide better classifications and yield more accurate solutions for future problems. The long-term objective is to increasingly cut the turnaround time for diagnosing infrastructure or application issues by at least 30%. Through analyzing historical incident data for trends regarding the initial items that our support analysts must spend time on researching. The proposed solution will increase overall system availability, translating into a direct cost savings to Google. And as downtime is reduced, there are additional indirect benefits that can be expected. Because the new system's output will integrate directly into existing service management tools, this will ensure that as more issues are resolved and the recommendations provided, there will be better documentation of the systems before, during, and after the event. As classification results improve and less time is spent on triage efforts, IT staff will have more cycles to spend on strategic value-added work, putting our business dollars to a more productive use. Finally, we know that system availability plays a critical role in the customer experience. When outages impact customers, it can require additional resources at help desks, or worse, it can cause customers to take to social media where they vent about their poor experience to a global audience. Modern technology has all but proven a chaos theory, that a single Twitter tweet on the other side of the world can cause a viral storm in our PR department. Avoiding these types of situations will enhance the overall customer experience, build trust, and over time, increase brand reputation.
In addition to obvious business benefits, there are also significant financial benefits. Time spent on outages and troubleshooting is not time spent generating revenue. This could be as costly as hundreds of thousands of dollars per hour, and this is a very direct cost to business. Indirect costs would include financial loss resulting from brand damage and litigation, which could have long-lasting negative impact on business. Minimizing these losses that result from outages and downtime by speeding up the time it takes to recover from an outage is crucial. We seek to build a system that helps us to do just that.
So what is our solution? A systems analytics recovery assistant. We call it SARA. Based on historical incident records and machine data aggregated in real time, SARA will classify each problem, connect the issue to related knowledge-based solutions, and recommend appropriate escalation teams. Classifications will start with generic issues such as application hosting, security, or network, and then drill down into specific technologies which are causing the impact. SARA gives immediate value to the first-level analyst owning every record by providing context-relevant information and key documentation to jumpstart a resolution. For ease of use and better documentation as the record is escalated, SARA's output will be logged into the same incident records the issue was reported under. This prevents the need to gather and document all of these details manually. It also helps overcome the fear of record ownership and cuts the time required diagnosing root cause. When escalations do occur, it also speeds the process of getting the incident record to the appropriate recovery team. We use BMC Software's Application Remedy Suite for our IT service management. In today's environment, monitoring alerts generate new remedy incident records, which are then assigned to a first-level team who begin researching for documentation and root cause of the issue. For example, if a server goes unreachable, it could be due to a network link down, a server hardware failure, or even a combination of issues. In the proposed solution, when new incident records are created, Remedy initiates API calls to SARA for classifications. Phase 1 of the project will determine classification taxonomy based on historical incident record. In later phases of the project, SARA will integrate with additional data sources to enhance these results and provide additional context. For example, by correlating log files to incidents, SARA can assist when multiple technologies are impacted by isolating issues to a single root cause. When an incident record is worked and then resolved, analysts will update any incorrect classifications to those that were used during the recovery, linking solutions to incidents is already a current ticket handling best practice. And upon closure of the record, a subsequent request will be made to SARA's machine learning servers, which will report the record's original observation data along with the actual values documented for recovery for each classification. Using this feedback loop will ensure that there's a constant training of the machine learning algorithms in order to adjust to a dynamic systems environment. The return classifications will be included under a new output tab for SARA within Remedy's incident user interface.
Okay, when a user opens a ticket that has appeared in their queue, they'll eventually make their way to this investigation and diagnosis tab. In this view, you'll see 4 tabs, one of them being the new SARA tab. All of the machine learning information will appear here. This area will provide a list of potential fixes, which are displayed with a confidence score. The details of the potential fix appear below. This will include data gathered from previous tickets, as well as log repositories and knowledge management systems results. Above the potential fixes is a button which, when clicked, will display a recommended response team, which shows a listing of personnel groups or where a ticket may need to be forwarded to next. Again, with a confidence score of 80% or more. And see here, the ultimate goal of this project is to bring as many data sources into play as possible. These 7 systems are only a subset of our enterprise, but each would benefit from our approach. Our various monitoring systems will be more centralized, analyzed, and parsed more easily. Bringing in system logs helps us become more proactive when troubles arise. Including our data center infrastructure management reporting could prevent network outages or help mitigate existing problems more quickly. Oftentimes, incident notifications are written via email and sent to group inboxes where triage isn't necessarily performed immediately. So inclusion of these inboxes would provide faster responses as well. Most incident response teams have a database or a form of historical records of past incidents, their causes, and their mitigation steps. These data sources would be extremely helpful to the new system and could provide incident resolutions across different areas. So we'll be implementing a phased approach with our solution. Phase 1 will run for 5 months and we'll have monthly evaluations. We'll be using data sources shown in the slide. Existing system log files, probably from a syslogger and the service management tools such as Remedy. Subsequent phases will be planned and scheduled upon outcome of the monthly evals. Sarah will parse the digital haystack of information to classify root cause and recommend solutions with confidence levels before the first analyst even owns the incident record. This will translate into reducing the time our support staff spends on impact recovery and will increase systems availability.
To reduce research time required to begin recovery, Sarah will provide 3 distinct classifiers that correspond to the new documentation being provided: root cause, solution artifacts, and escalation work groups. The root cause is intended to give the owning analyst a head start towards diagnostics by indicating which technology is the actual source of the failure. In phase 1, these will be high-level technology stacks such as network, application, or hosting. In phases 2 and 3, Sarah will correlate events across the enterprise through integration with system log files and configuration management database. Root cause will then become more specific, drilling down to a single configuration item or a master incident record. Solution artifacts are relevant knowledge-based documentation for known issues and standard operating procedures. Currently, analysts are required to research these items and link them to incidents when used for recovery. Sarah links classifications for them upfront, reducing this research time. Escalation work groups are Sarah's recommendations for the appropriate engineering team to engage. Escalating a record requires substantial manual documentation and cross-team communications. It is important to minimize escalations because it not only delays recovery, but it also engages higher cost support staff, which can't assist with the issue.
At the heart of Sarah is the machine learning implementation of a classifier. Naive Bayes is the machine learning algorithm that we have chosen for phase 1 of our project. It is a supervised learning approach in which the system learns from training data input given to it. After the training, the system is able to classify new observations or tickets. We choose Naive Bayes for the following reasons. It's easy to implement in a high available setup, and high availability is very important because Sarah must be up and running at all times. The software is also free, and the Naive Bayes classifier is also very simple, easy to understand and implement, and very fast. And lastly, it integrates very easily with monitoring tools, the ticketing system, and our logs repository. With respect to additional implementation details, we will be running a high available Hadoop cluster of servers, running Apache Spark, MLlib, and Zookeeper, which will be used to manage orchestration and failover. Zookeeper will ensure that the standby name node is swapped in if the active name node fails. There are also several data nodes for redundancy. Additional details of server specs like disk, RAM, storage are there in the full paper. Sarah will integrate with the ticketing system for continuous and ongoing training of the machine learning model. It will also integrate with monitoring tools and logs repository for additional data which will be processed and correlated with the incidents. Let's take a closer look at the logs repository. The logs repository will be an Elasticsearch high available and scalable cluster. Servers and data center devices will write their logs to the Elasticsearch cluster over an Nginx load balancer for high availability. Sarah will read logs for patterns and update the ticketing system after processing the logs and correlating them with incidents in Remedy. Systems development will include a development and configuration phase, as well as a training phase for the machine learning model. Development and configuration of software components will initially be done in a development or dev environment. We will obtain, deploy, and configure stable versions of Hadoop, Remedy, Spark, MLlib, and related software from vendors. We'll use an iterative agile process during development. To train the classifier, we will use Remedy's historical incident records as training data. A random sample of 5% of the historical incident tickets will be withheld to serve as a test set. After training, validation will be done against the test set. We will target over 80% classification accuracy in phase 1 before moving system into production. There will be continuous and automatic training over time. This will be achieved by having Sarah ingest closed incidents from Remedy on a daily basis.
Following the development period, there will be a 3-phased implementation. Phase 1 will involve rolling out the production infrastructure, integrating Sarah with the log repository and production Remedy records, baselining system performance, and training the users. Phase 2 will integrate more data sources and enhance existing ones through feature engineering. The additional data for this phase will come from expanding upon log file ingestion and the configuration management database. Feature engineering will provide Sarah's learning algorithms deeper context into the data sent to the classifier. A simple example of this is when using the time an incident occurred as a predictor. Classifications based on time become better when it's considered within additional business context, such as, is this time during normal business hours or even peak production time? Ask yourself, would it help to know whether it has been milliseconds or months since the last time this very same incident occurred? Phase 3 will make use of additional learning algorithms to identify potential for better classifications through ensemble learning. By providing multiple learners and then identifying which works best for each classification, results can be fine-tuned to prefer a base algorithm or a combination.
All right, so during phase 1 rollout, we will gather 3 monthly user feedbacks via an online questionnaire. Each questionnaire will gather usability results and improvement suggestions. A committee will determine which of these results or suggestions are priorities and will potentially recommend them to be added to the subsequent phases. Greg, you're on the mute there, buddy.
Training analysts for the new system will focus on 2 objectives. The first consists of familiarizing analysts with the new features provided by Sarah's output, where to locate it within Remedy incident records, and the value it provides to their daily activities. For this, there are 2 training paths, a standalone module for analysts already trained on the Remedy suite, and an update to existing training to include these same concepts when onboarding analysts. The second course will focus on the role analysts play in closing the learning loop. As new incidents come in and supporting documentation is created to address these new situations, it's critical that classification fields get updated in the incident record prior to closure. This ensures that the machine learning algorithms will adjust to changes in the system environment over time. And these updates include linking solution artifacts and root cause configuration items. Although it's already best practice to update these fields when working records, this course will reinforce the importance to the machine learning loop to our analysts. It will be delivered as a standalone module to all current and new system analysts. All training will be provided in the form of online self-paced courses delivered through our existing learning and development management systems and will be made available prior to the production implementation of phase 1 with a live training application available in the test environment.
We will evaluate our progress during the project by sticking to the following activity and value-based success criteria. The activity-based success criteria include the following. We must meet the phase 1 release date of the project. The release of phase 2 must happen a month after the final evaluation period of phase 1. We will also stay within a budget of about $200,000 for phase 1. The value-based success criteria will include the following. reducing the time it takes to resolve incidents by about 20% for phase 1 of the project, reducing outage durations resulting from incidents by at least 10% by the end of the year. And lastly, we will also expect savings of at least $12 million from lost revenues resulting from outages within the first year.
Hey, and this is our proposed timeline for the project. So during the first month, it kicks off with the installation of our new infrastructure, followed by development. From there, we move into a month of testing, a move to a simulated prod environment, and then to user acceptance testing. The solution will then be rolled out to production where users will be trained, and then they'll perform their duties with the new system in place. They'll do this for about 3 months. And at the end of each month, the project manager will request the user feedback I discussed earlier, and evaluations will be conducted based on metrics and criteria which Jay just discussed. So with that, are there any questions?
Okay, the floor is open. Who has questions for these folks?
Great, a really interesting project. There's a great use, a great need for this kind of a project. My camera's not on. My question is how time actually relates to it. You touched on it in one of the latter slides, but there's a problem that occurs a month ago, a year ago, and 5 years ago. You're making a predictive model that leverages all the information, but how do you build the fact of that things have been changed and patched and fixes have gone along the way into making the right choice of what you present the user?
We have an ongoing learning process where at the end of every day, the system continuously learns from incidents as they have happened very recently, and the model gets continuously trained. You could think of it as a batch job which runs at the end of every day, and tickets that have gone through the system and closed are ingested by the classifier, and in that way, the system does not, the model does not stay static, it's dynamic. And over time, it learns and performs better.
Yeah, I can follow up on that too. So we mentioned in the paper that there will be changes, and we anticipate those changes. And this isn't going to hit 100%. We know that. And so what we're trying to do is minimize what our analysts are having to research to the outlier events. And those are going to be the new things that come across when new supporting documentation comes in, when new technologies come in, as you mentioned, when patches or new products are rolled out. And those are the new things that the analyst will have to take charge of when those come in and the classifier doesn't get it right. And that is the whole reason for enforcing the learning loop to our analysts.
So I think you've addressed half the question. If I could redirect the other half. So the half that you address is that you get the most recent stuff in, and you can't predict the future. There are things you haven't seen yet, of course. But there's also the stuff that's old that probably shouldn't be a root cause because it's no longer applicable. Do you drop things as well from the records in your prediction system?
Yeah, so we anticipate as those records come in and those solutions are no longer used, that the machine learning algorithms will adjust to those, because not only are they linking new solutions, but part of the training is removing solutions that didn't apply as well. We may have missed enforcing that point, but yeah, new solutions, our legacy solutions will definitely have to be detached, and so that's part of that learning loop as well. Does that address your
Yes,
question?
it does. Thank you.
Thank you.
Yeah, I have a question. So it seems that basically, the training information is all of the remedy tickets. Is the system, able to ingest other sources of information as well, such as knowledge base articles that your analysts may have written in the past, or manuals, things like that?
So for phase 1, no, but there are other phases in which we add to the data sources and also help improve the system and the level of detail of the recommendations that it makes. So those are the additional data sources are things that we have considered, but for later phases that is beyond phase 1, which is what we're focused on at this point.
Okay,
Right.
thank you.
In addition to that, so you mentioned the documentation come along. That actually is one of the outputs of SARA. So there will be documentation that provides standard operating procedures when certain incidents occur. And those are things that are linked into SARA. So as far as the documentation, that is one of the classifications that's provided by the system. But as Chase said, we will ingest more data over time and into the system. And our hope is that when we first started this project, we envisioned that the pinnacle of all of this would be that when we get the system honed to a fine level of accuracy, that we can even employ automation on top of this and say, we don't need to send this to a first level analyst if the system can, based on log file ingestion, determine that there's a specific server that just, maybe it needs to be rebooted, or maybe there needs to be some disk cleanup, or so we to narrow scope on this project and to have achievable results within a limited time frame, we didn't include the automation aspect in the paper, but that was something that we wanted to, we did want to include. We just felt we didn't have it for the scope of this project.
Okay, well, that's very interesting. Thank you.
May I ask a question? I am, yes, it is very much needed, and everyone wants to have it. But what I'm missing something. I'm missing something in my basic understanding, and that is, what do you get from a log file? That's a short question. But the longer question is, you have a bunch of incidents recorded with the root cause recorded in them and a bunch of nodes during the resolution, right? So you have that is your training data set. That's your knowledge base. So you basically will make your analytic algorithm to establish a relationship between the description in the ticket and all the parameters in the ticket, and initially just to the classifier of where the incident is from, hosting versus operations versus database. But then you connect it to the root cause and you say, if this is in the reporting part of the incident, this is the root cause and here is the resolution. Is that the type of logic you're looking for? And could you give me an example of how in your phase 2, you will use the parsing of a log to help establish the relationship in the new incoming incident? Am I making my question clear?
We can start providing an answer, and then if our answers fall short, you can ask again on the part that we didn't cover properly.
Thank you.
So the initial system is a naive-based classifier, which at a very basic level would look at text and then try to assign it a category. And this category could be a root cause, it could be an escalation group, or it could be a name of a training resource.
Excuse me, which text are they looking at the classifier job? The ticket text?
Yes, the incident text that's coming from a monitoring system and it's being reported to the ticketing system. So at a very basic level, that is what we do. And at a very basic level, we do that classification. We take that text, we give it we assign it to these categories. At this point, we're talking about 3 categories. So right there, at that very basic level, we already have a functioning system, a bare bones functioning system. Now, for logs, and what we are thinking is when a report is made to the ticketing system, it generates an event which then can make a call to the classifier, SARA, the machine learning server, and that machine learning server can then reach out to the Elasticsearch log repository and can then correlate, because the ticket comes in, it has the name of the server in it. Usually it comes in, most of these systems would send you a JSON and the field is well defined. You can then use that, say the host name of the server, and then in the logs you can say, hey, Elasticsearch cluster, please tell me if you have a log that has come in within this time frame. that has this server name in it. And again, this is another bare bones example. You can then pull that data now and then attach it to the ticket as additional information for the ticket. I don't know if that helps address how the correlation happens.
Yes, it is. You have helped me understand it better. So what I've heard, thank you, Chair, you're saying that the ticket, the incident itself, the ticket itself was generated based on the instrumented monitoring system, that the monitoring system was able to generate the initial event, push it into the automatic generation of an incident. And that is why you would have enough data to correlate back to the log.
Right. Yeah. And also, as mentioned in phase 3, when we get into ensemble learning, that's where we hope to say, let's start classifying based on the data from the incident. Let's grab some related information to that server that was logged as going down, or when we reference the configuration management database, we can look at upstream services as well and correlate those. And can we come up with a better classification based on that additional data than the original classification that we had?
Right, and that will be extremely useful and valuable if you reach going up the stack, if you get to the health of a business application and a business process. This is what everyone is after. And today we do it by manually devising rules and relationships. There is no ML involved. It is just, we say, correlate this to like any layer of the stack, the events, if they, like security versus database versus hosting, wherever it happens, it impacts this business process, right? And the SLA for the business will be impacted as well. So if you do it within ML, it will be extremely valuable at all levels. Thank you.
Okay, anything further? Okay. Congratulations, guys. You are now done.
I'll applaud that.
Yeah. Okay, Greg, thank you so much for all your hard work. Really appreciate it. Yeah.
So, all right.
Very nice job, everyone. Really impressive projects.
Thanks.
So.
Congratulations. Thank you.
All right. A couple of ending comments here from the PHB. And for those of you, the guests, the PHB is my alter ego, the pointy-haired boss that has been putting these guys through the ringer for the entire term here. So a couple of summarizing things. You guys are all finished. You all did some really great work tonight. I know this has been a long road when we started off in the dark days back at the end of January. And if you look at the window behind me now, it's still it's still somewhat light out there. So we've come a long way in that respect. Everybody started off with a very sparse idea, sometimes way too wide, sometimes way too deep. We did a lot of work on them. Everybody worked extremely hard to make this happen. Unfortunately, we lost 2 people through the term just because of a weather event, which was really unfortunate. And I'm hoping to see them at a later date in another class. So I also like to thank all the faculty committee members who put in time tonight to spend with us. Zoya, Peter, Sylvain, Eric, and Takayuki, thank you very much for doing this. Much appreciated as always. Okay, so we are now out of the woods with this. I'm just going to leave you with one admonition from my personal perspective here. You guys have all picked up a lot of information throughout this whole experience, not just this class, but also the program in general. And I don't know how many of you, I know Damon has military experience, but I don't know how many of the rest of you will know this term. I want you to all now go off and become what we called force multipliers. I know Josh also knows this term as well. A force multiplier is somebody who has been trained to a fairly high degree of comfort in a specific area of expertise and is now tasked with going off and training other people. So You guys are all now force multipliers. You all have a high level of expertise in a variety of different areas involving IT. Go out, disperse that knowledge, sprinkle it to all your colleagues, spread it out, make it count. And I've also told you all that when you get out of this program, you are now going to be considered leaders in your groups because you are coming out with a master's degree from Harvard. Take advantage of that. Use that. Become those leaders. And for that, I will get off my soapbox and let you guys all go. Thanks also to Christina for another stellar job throughout the term with helping out. So, and we will be getting the final grades together over the rest of the week, and we will try to get those to you before the weekend so that you can now exhale and relax and get ready for commencement if you are commencing or whatever term you're going on to if you still have a course or two left to go. Thanks very much, folks. Any final comments from out in the field, or shall we close it all down?
Thanks a lot.
Thank you.
Congratulations.
Thank you.
Thanks, everybody.
Okay. Now you all have to find another way to fill your Tuesday evenings. So it's up to you. And by the way, just as a last note, we did put a comment on. There's a discussion open on Canvas about a get-together. We're thinking maybe the 23rd. So anybody who's coming to town who's actually going to be in commencement, if you want to get together, and this doesn't have to be with us necessarily, but if you guys want to self-organize or if you want to put out some ideas about getting together for dinner or drinks or something like that. See, we get to do this during Zoya's presentation because she has an on-site component to it. So there are a bunch of us actually at Harvard. So this is the only way we can do it when we're 100% online. So if anybody's interested in that, pop something onto Canvas saying yes, no, not interested, whatever, and we'll see what we can get together. Okay? Thanks very much. Signing off for the last time this term. Have a good night, everybody.
Night.
Bye.
Well, that was appropriate. Oh, and by the way, Che, since you're still on here, you can extemporaneously answer questions better than most people I've ever met. You did a really good job of picking up on that question and taking care of it.
Thank you. Thanks.
Seriously, you think on your feet so well.
Thank you. Yeah.
Use your powers wisely.
Exactly.
I'll try. Thanks, guys.
Just remember, it's Spider-Man. With him, with every great power comes great responsibility.
Thank you. Thanks.
Congratulations again.
Yeah.
All right. I'm going to end the recording.